What if we're asked questions about continuity of a function, but we don't have a graph? Instead, we have a formula. In this case, we have a piecewise function. So up at the top there, we've got two questions about f. First of all, is the function f continuous at x equals -1? And then is it continuous at x equal 2? So we can use these three rules of continuity to make a decision on that. So let's suppose we've got the first one where x is equal to -1, and I'm going to look at this first rule, and it says that f evaluated at -1 has to exist. And according to this piecewise function, if x is equal to -1, then because of the symbol here, that puts us in this situation. So if x is equal to -1, it lives in between -20 and less than or equal to -1. So I will use the first formula as my formula for f, and f evaluated at -1 is going to be +1 plus 3, which is equal to 4. So after all of that, we have that this is equal to 4. So now I'm going to clear that away. Okay. Now let's see what the second condition is. The limit as x approaches -1 has to exist. Okay. Well, what is the limit as x approaches -1? Well, let's look at the left-hand limit. What happens when x approaches -1 from the left? So when your x values are to the left of -1 on the number line, like -2 or -3. Well, if they're on the left on the number line, again, that's going to put us into this situation, which is going to give us this formula. And I'm just going to plug -1 into that formula. And I'm going to have +1 plus 3, which is 4. Okay. And now let's look at the right-hand limit. So what happens as x approaches -1 from the right on the number line? So if we're to the right of -1, that's going to be putting us into this situation here. X is some number strictly between -1 and +2. And so the formula is now going to be -4x. And I can just plug -1 into that. So my left-hand limit and my right-hand limit are the same. Therefore, the limit exists and it will equal 4. So there's my conditions 1 and 2 satisfied. And now let's look at what the third condition says. The third condition says that what you got in answer 1 has to be the same as what you got in answer 2. And they both must exist. So we have that this limit was in fact 4, which was what f evaluated at -1 was. So the answer to this question is a resounding yes, it is continuous at -1. All right, now what about here? Let's look at problem number 1 from the three rules of continuity. F evaluated now at 2 has to exist. And so if x is equal to 2, where do we live? Well, we're not in this first condition. You only use that formula for x values between -20 and -1 inclusive. We're not in this second condition because you use this equation when your x values are strictly between -1 and strictly lower than 2. And so we can see here, if x is equal to 2, this is the formula that we use. And so f evaluated at 2 is going to be that, and 11 minus 2 is 9, and the square root of 9 is 3. So the first condition is satisfied, f of 2 exists, and it is equal to 3. All right, so far so good. Now let's look at that second condition. The second condition says that the limit as x approaches 2 of f of x has to exist. Let's look at the left-hand limit. So as x approaches 2 from the left, so we're a little bit smaller than 2, we're a little bit to the left of 2 on the number line, we're in this situation, and so that's my formula. And so if I plug 2 into that formula, I'll get -8. So my left-hand limit is -8. Now what about my right-hand limit? As x approaches 2 from the right, so from numbers that are a bit bigger than 2, then x is going to live in there, because my x values are numbers that are to the right of 2 on the number line. And so that's the formula that we will use. And so if I plug, sorry, there's an x there, not a 2. And so now if I plug 2 in for x, I get the answer 3. Now we have a problem here. My left-hand limit is not the same as my right-hand limit. Therefore, the limit does not exist. So my second property here, my second rule, is violated. Therefore, is f continuous at x equal 2? No, it is not. So I don't even need to check the third one. As soon as one of those is violated, our answer is no. Okay. All right, so I hope that that helped you some if you had, say, a piecewise function and you were asked questions about the continuity like this. Thanks for watching.